Okay, this is a walkthrough of the Chapter 1 test, Test 1A. So it will be a practice test for the Chapter 1 test for AP Statistics. Let's look at these. So there's probably not going to be a lot of work on some of these, but I'll talk through and give some thoughts that I'm thinking. Pie chart at the right describes the distribution of state tree types for the 50 states in the U.S. The category Other includes all trees that are the state tree for 2 or fewer states. 2 or fewer. Okay. Which of the following conclusions can we draw from the chart? Some states have not designated a state tree. I can't tell that because in order to tell that, I need to know how many individuals, and I don't know that all 50 are there. The cottonwood is the state tree for 12 states. Where's the cottonwood? Cottonwood. 6%. 6%. Well, 6% of 50 is 12, right? So 0.06 times 50 is, no, it's not. I don't know why that's even thinking there. There's cottonwood, 6% for 12 states. No, I don't know that because I know it's for 12%. And even if it was 50, that would be assuming that all 50 had a state tree. So I don't know that. Taken together, oak, pine, and maple are the state trees for more than half the states. Oak, pine, and maple. Here's oak at 12%. Here's pine at 20%. So 12 plus 20 is 32 plus maple. Maple is 10. 20 plus 12 is 32 plus 10. That's 42. That's not more than half. There are 10 states that have designated a pine as their state tree. There are 10 states that have designated pine as the state tree. Well, 20% have done pine. And if I go 0.2 times 50, that tells me 10. So assuming all 50 did it, I could say that's true. So I'm going to put that. There is no state tree that has designated the eastern red cedar as its state tree. Eastern red cedar. I don't see the eastern red cedar. Sorry, I had a thought for a moment. There is no state that has designated the eastern red cedar. Well, I don't have these. But see, it's all of this. These are just kind of miscellaneous trees, and I don't know where they are. So I don't know that. So I know this is wrong. And this is the way a lot of these questions are. I know this is wrong. I know this is wrong. Now, some states have not designated a state tree versus there are 10 states. This one, I don't know that that's wrong, but I don't know that it's right. But if I make an assumption, this is the only one that will work. And if I look, the pie chart on the right describes the distribution of state tree types for the 50 states in the United States. So it kind of implies that all 50 states are there. So if 50 states are there, this one, and this one cannot be correct. This might be correct, but I don't know that. This one is definitely correct. So it's D. Okay? The reason I know it's not this one, some states have not designated a state tree, is this chart doesn't tell me anything either way there. Okay? But the prompt says it's for the 50 states. So we base with that the assumption there. Okay, number 2. So there's some thinking here that goes on. Number 2. The following bar graphs gives the percent of owners of 3 brands of trucks who are satisfied with the truck. From this graph, we can conclude that, okay, Ford, Chevrolet, Toyota, percent satisfied. The owners of other brands of trucks are less satisfied than the owner of the 3 brands. I don't know anything because the graph doesn't tell me about any other brands. All it tells me is Ford, Chevy, and Toyota. Chevy owners are much more satisfied than Ford or Toyota owners. That seems to be true because 97% of them are satisfied. Now, I'm doing this much more because it looks like, look, check it out. I've got, this is 95 and this is 97. So there's only 2% difference, but they are more satisfied. So I'm going to hold this. There are only small differences in the satisfaction of owners for the three brands. That I just noticed because it goes 95 to 90. It's under 2%, right? Chevy probably sells more trucks than Ford or Toyota. I know that's false. A pie chart would be a better choice for displaying these data. No, because a pie chart would have to be the owners of all trucks, and I don't know a pie chart is when you know all of the things, and you would say, have what percent of owners. This is saying what percent. So these could all have 100% in them, and that couldn't be displayed in a pie chart. So I really don't like this much more satisfied because these aren't much more. There's only a small difference in these. So you're going to start looking for things, and check out the instructions, and the AP test is the same way. Circle the letter corresponding to the best answer. Okay? Their Chevy owners are more satisfied, but I take issue with that much more, and 2% is not much. Okay? I hate to say it. Okay, sorry. Stop for a Coke break. Okay. Here are the test scores of 10 randomly chosen 5th grade students. 145, 139, 126, 125. Okay. To make a stem plot, you would use the stems. Okay, so stem plot. Remember, we've got stems and leaves. And the leaves are single digits. So if I look 145, it would have to be 14.5. Okay, so that's how it. But 0 and 1, no, these are like tens and ones. I would use 0, 9, 10, 14. My stems would be here 14, 13, 12, 12, 12, 13, 9. Oh, so there's 0, 9. There's 11, 11, 11. So I would use 9. Would I use 10? I don't see a 10 in there. So I wouldn't use 10. I would use, so let's just put them all together. I would use 0, 9. Oh, sneaky, sneaky. Check this out. I have to go 9 to 14. And I was just about 9, 10, 11, 12, 13, 14. So I've got 9s, and I've got all the way up to 14. 9, 10, 11, 12, 13, 14. I would have to use all of these stems. Let's look at this. 96, 110. Okay, these are obviously wrong. 0, 2, 3. Nope. This is the one I would have to use. Now, where you might get caught up is saying, oh, there's nothing in the 10s. But you would still have it, right? Because this would be 96. And then the next one you would skip is, you would go to is 110, 118, and so forth. Even though you don't have anything in this 100 stuffs, it would still be one of the stems. You don't skip stems. So there it is, B. So far I've got D, C, B. Okay? If the distribution is skewed to the right, so I look at things visually. Skewed to the right. There's that. And I'm looking at this mean, median, mean. Oh, so I'm thinking, remember what I told you? There's the median. There's the mean. The mean must be less than the median. Nope, the mean is greater than the median. The median must be equal. Nope, the mean must be greater than the median. That's it. I'm going to read my other answers. The mean is either equal to, nope, it's not. It is impossible to tell. Nope, bullpucky. I know that the mean is greater than the median. So it's going to be C. Okay. Okay, I hope I'm getting these all right. D, C, B, C. I'm going to real quick check these back here. D, C, B, C. Perfect. Oh, I don't feel so dumb. Okay, moving on. I know you're here. Okay. Rainwater. Number 5. Rainwater is collected in water collectors at 30 different sites near an industrial complex, and the amount of acidity pH levels measured. The data from pH ranged from 2.6 to 6.3. The following stamp plot was connected. Okay, there's my 2.6 and there's a 6.3. And there's pH. Okay, there's my key. Which of the following is a correct representation of the same distribution? Now I notice, look, it goes from 2.6 to 6.3, 2.6, 6.3. All of them go from there except for D. So that one I can scratch off right now. Okay, I'm looking at these. These three have the same medians, and these three have the same third quartiles. This different. But look at this. See how this first quartile is different in every one? So I'm going to find these. So 30 different sites. So if I cross off 30 divided by 2 is 15. So if I count in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. My median's right there. So the median is 40 between 4 and 6, 4.5. So the median is right there. So I can scratch this one out. Okay. Now I had to find the median to find the quartile, right? Yeah. First quartile. So there's 15 in this first half. 15 divided by 2 is 7.5. So it's going to be 7, and right after the 8th one. So 1, 2, 3, 4, 5, 6, 7, 8. There's my first quartile. It's 3.8. So quartile 1 is 3.8. Where is that? 3.5. Well, it's 3.8, which is right here. So it's B. I don't even have to bother to figure out the third quartile because that's the only one with the first quartile of 3.8. So I guess maybe I needed to find my median. Well, that one has that same quartile. This is certainly not 3.8 because 3.8 is more than halfway over. So it's that one. B. Cool. Moving on. Okay. A sample of 250 high school students were asked, if you had $1,000 to contribute to one kind of charitable organization, which kind of organization would you choose? Below is a two-way table of responses to this question and gender. Okay. Okay. So before I start making totals and get my distributions and stuff, I want to know what they're talking about. Which of the following conclusions seems to be supported by the data? Most of the females who chose a health organization would have chosen an environmental organization as their second choice had they been asked. Most of them who chose a health organization. So these are the ones that chose. How do I know what their second choice is? I don't, right? Because all I know is their one choice, right? Because this is 250. I'm going to triple check that bit. 19 plus 33 plus 50 plus 28 plus 10. There's 140 females. 23 plus, I'm adding up the boys now. 29 plus 28 plus 17 plus 13, 110. Yeah. So this is only one answer. So here it is, their second choice. I don't know anything about the second choice, so that's done. There is no association between gender and choice of organization. If there's no association, that means that proportionally, these are the same and this is the same and that kind of thing. So the way I can look at that is I can go 19 out of 140. 19 out of 140 gives me 13.5. That's 14%. I'm going to just do percentage here. 23 out of 110 gives me 21%. Actually, right there, that tells me that there's probably an association because these are different. If there was an association, I would see that the same percentage of females that chose education would be males. So let's look at environment. 33 divided by 140 gives me 24%. 29 divided by 120, 29 divided by 110 gives me 26%. That's close. Oh, look at this. Oh, this is absolutely. Those are so different. 50 divided by 140 is 36%, where 28 out of 110, that's not even close. That's 28 divided by 110. Sorry, I typed in the wrong thing. That's 25%. These are so far off. These are so far off right now, the proportions, that I could think there's definitely an association. So there is definitely an association. The proportion of males who said they would contribute to an environmental organization was higher than the proportion of females who said they would contribute to such a. Well, I've already found that 26% of males said they do environment, 24% of females. The proportion of males who said they would do environment was higher. That's true. Okay. None of the students surveyed said they would contribute to religious organizations. A religious or not religious, not religious, not religion, not religion. Other. Oh, I don't know what the devil is. Other. Other could be religious or terrorist or whatever organization. So they could do all kinds of stuff. Well, charitable. Is a terrorist organization a charitable organization? Don't think so. So that couldn't be there. Sorry, I'm trying to be funny and it's not. The marginal, yeah, maybe it is. The marginal distribution of organization is 140, 110. Okay, the marginal distribution of organization would be down here. That would be these totals, like 23, 45, 78, 62, and 42. That would be the marginal for organization. This is the marginal distribution of gender. See, 140, 110. The distributions don't necessarily have to be in percentages. They can be in counts, right? Right. Okay, so this is not true. This is not true. Well, this, I don't know if this is not true, but it could be true because the religious organizations could be other. This is definitely true. So C. B, C. Number 7. I hate multiple choice questions. I don't like them because they can be challenging. The key to multiple choice questions: read thoroughly and consider all the answers. Okay, you've got to do that. These are not questions that you can do just thinking, just looking at them. Think, it looks like it. I can't do it. So write all over them. Think about them. Put some thought. Small company that prints custom T-shirts has 6 employees. Let me get up here. I'm looking at number 7. One of whom is the owner and manager. Suppose the owner makes $112,000 a year, and the other employees make between $40,000 and $50,000 a year. Ooh, so he's a high value. He's probably an outlier, right? One day, the owner decides to give himself a $30,000 raise. That sneaky owner. Which of the following describes how the company's mean and median salaries would change? The median would both increase. Now, hold on. Time out. Think about this for a second. If I add up their total salary, total of all their salaries, and divide by 6, because there's 6 employees, that's going to give me my mean, right? So if I increase that total by 30,000, check this out. 30,000 divided by 6, that's 5,000, right? Because remember, I can split up the fraction like that. 30,000 over 6 plus the total over 6 is going to be the new mean. So that's going to be the new mean. So 30,000 over 6, the mean is going to increase by 5,000. So the mean is going to increase by 5,000. So I'm going to look at this. The mean and median would both increase by 5,000. I don't know. The mean would increase by 5,000. That's good. So that's true. The mean would increase by 6,000. That's not true. So C is gone. The median would increase by 6,000 and the mean would not change. That's not true. That's done. The mean would increase by 6,000. That's not true. So the mean and the median would increase by 5,000. I don't know that. Do I? Think you got your 6 people. 1, 2, 3, 4, 5, 6. And then your owner's out there, right? And if he increased his value, oh, you know what? The median's right here, right? No. Oh, that's 7 people. So that guy just got fired. The median's right here. And by increasing this, the mean doesn't move over a bit. So the median would not change. There it is. B. B. Okay, cool. Number 8. The mean speed of vehicles in the cars-only lanes of the New Jersey Turnpike is 68. So that's my X bar. Miles per hour. The mean speed of vehicles in the any vehicle lane is 64. So that's, let's call it Y bar. Because it can't be X bar because I already got an X bar. What must be true about the mean speed of all vehicles on the turnpike, assuming these are the only types of lanes? It could be any number between 64 and 68. Okay, I know it's between 64 and 68, right? It must be larger than the median speed. I don't know that. Do I? Because for the median to be larger than the mean, it's got to be skewed left, because there's your median and there's your X bar, right? Do I know anything about the shape? All I know is the means of the two areas. So I don't know that. It must be larger than the median. I don't know. It must be larger than 66. Well, let's think about that. The cars only is 68 and any vehicle is 64. If it was higher than 66, that means it's closer to the 68, which means that there would be more cars in the cars only lanes of the New Jersey Turnpike. Do I know that? I don't. I don't know anything about the number of cars versus any vehicles. I don't know that. Okay? Maybe I should have put a star on that. I don't know that. Well, I know this is true. It could be I know it's between 60 and 460. So right now I think that's my best choice. Because I don't know this. I don't know this at all, but this, I know this has to be true. This might be true, this might be true. This is definitely true, but it might be something better than that. It must be no. It would only be 66 if there were equally amounts of cars in 68 and 66. In 68 and 64, then it would be equally weighted and it would be right smack in the middle. We don't have enough information to draw any conclusion. No, I do know that it's between 64 and 68. It can't be 64 because the cars here are going to cause it to be higher than 64. It can't be 68 because the cars here are going to be higher, are going to cause it to be lower than 68. It's going to be somewhere in the middle there. So it could be any number. Could be any number. I'm fishy on that one. I'm 99.9% that's right. And yeah. Okay. I feel really I always question myself. Okay. And maybe that's the way you should do it. Try it yourself, choose an answer, commit, and then go see it, and then see, oh, why am I right or why am I wrong? 9. The mean birth weight of infants born in a certain hospital in the month of April was 120 ounces, so that's X bar for April. I'll call it A bar. Yeah, because April. With a standard deviation of 10.2, so that's my standard deviation S sub X, or S sub A, since I'm dealing with A. Which of the following is a correct interpretation of the standard deviation? Now, time out. When it says definition, interpretation of standard deviation, remember what I told you. Standard deviation is the average distance from the mean, right? Okay, so I'm looking for something like that. All the infants born in April weighed between where are these getting numbers this from? 120. Oh, you know what? 128 minus 110.2 is 1 set. So that's 1 standard deviation less, and that's 1 standard deviation more. I don't know that. They're about that far. It doesn't say they're all within that, so I don't know that. About half the infants born in April weighed between that. I don't know that either. I just know that on average, they're about that far away. The difference between the mean weight and the median weight, and I don't know anything about the median, do I? Because to know that, you'd have to know the shape of that. I don't know that at all. So I don't even want to finish the difference between the mean weight and the median weight of April. It was 10.2. That implies that I know the median. I don't. The distance between the weight of each infant born in April and the mean weight was, on average, about 10.2. The distance between the weight of each infant born in April and the mean weight was, on average, about 10.2. That seems to fit with the average difference from the mean, which is distance. Yeah, is 10.2. So that one looks good. I like this. I'm not going to kill it yet. E, the mean weight of infants born in subsequent month is likely to be within 10.2 ounces of the mean weight in April. I don't know that because all this data tells me about is April. Just because you know April doesn't mean you know May. So that's there. It's D. So that's A and that's D. Cool. 9, 10. And that's the last one. This is the last one, then I can get to not multiple choice and I can be much happier because I like them. Whew. Now, if you're getting the idea that the multiple choice are not easy, you're dang straight. Multiple choice questions are not always easy. You have to read them very carefully. Okay? There's been 10 multiple choice questions, and so far it's taken us about 27 minutes to do them, to talk about them. That means, wow, I'm moving a little slow, but I'm also talking through everything's. A medical researcher collects healthy data on many women in several countries. One of the variables measured for each woman is studied is higher pounds. The following list gives her 5-number summary, so that's a 5-number summary. So I'm looking at that. That's the minimum, maximum, quartile 1, quartile 3, median, minimum, maximum. Okay, for the weights of adult women in the one of the countries. About what percent of country had women between 110 and 240? 110 and 240. Oh, hey, check that out. That's from quartile 1 to the maximum. Remember, quartile 1 is the 25th percentile mark, which tells you 25% are lower than that, which means 75% are higher than that. So 75% is my answer. C. C as in 75%. That's how you spell. Dumb joke. Sorry. Okay, moving on. Say hello, and I know you're here. I heard some of you. Okay. Part 2, pre-response. Okay, let's talk about these. We all know that the body temperature of a healthy person is 98.6, right? And if you have a fever higher than 100.4, you should not come to school because that means you might have the COVID thing. Okay, in reality, the actual body temperature of individuals varies. What? Yeah, that's why we don't say if you have higher than 98.6, stay home. Because fever is... Anyway, okay, enough discussion. Here are dot plots and summary statistics of the body temperatures for 90 healthy individuals. Females, males. Okay. Wow, look at this. That's kind of nice. Now, if I'm looking at this immediately, I notice that shapes. These are kind of symmetric on each one. This seems to have a higher center than this one. Outliers. These maybe are outliers and maybe something low. I don't know. Determine if there are any outliers in each distribution. Oh, speaking of, show your work. Show your work. Oh, now look at this. Ooh, we haven't seen this other than maybe in your homework. Look at this. Female. Mean, standard error, mean, standard deviation, minimum, quartile 1, quartile 3. So I don't have to come up here and find quartiles. I can go, hey, let's look at females. The interquartile range is 98.8 minus 97.9. 98.8 minus 97.9 equals, what is that? 98.8 minus 97.9 gives me 9/10, so 0.9. 0.9. For males, the IQR is, there's my quartile 3, 98.6. Guys are better. We Wait a second. No, that should be like the median or the mean, right? Whoa, you mean it's not? Oh, guys are not better. Women are hotter. Because see, there's that thing, maximum thing. That's interesting. Okay, 98.6 minus, that sounded bad. 97.6. I can do that in my head. That's 1. Now, 1.5 times that, 1.5 times 0.9, 1.5 times 1. I'm kind of doing these both at the same time because remember, outliers are where it's 1.5 interquartile ranges either above the third quartile or below the first. So 1.5 times 0.9, that's 1.35. 1.5 times 1, I'm really good at my 1 times tables, 1.5. So with females, high outliers are going to be 98.8 plus this 1.35. Low outliers are going to be 97.9 quartile 3 plus 1.5 IQR, and then so it's higher than that and lower than quartile 1 minus 1.5 IQR. Okay, quartile 1, 97.6 minus 1 this 1.35. Okay, so that's gonna that's males. 97.9, 97.9. So if I go 98.8 plus 1.35, 98.8 plus the 1.35, which is the 1.5 interquartile ranges, I get 100.15. 100.15. Okay, my maximum is lower than that. So there's no highs. So I'm going to say there's no highs. And I'll put an X through it just to tell me. Low outliers, 97.9 minus the 1.35 gives me 96.55. 96.55. Are there any low ones? No. Look at. Well, wait. What's the minimum? Minimum 96.4. Ooh, look at that. The minimum is lower. So for females, and look at this. Where is it? Females. It's 96.55, which is kind of right there-ish. Females, that's a low outlier. One low outlier. Males, and no high. No high. Males. For males, I have to take their third quartile. So I'm looking at highs and lows. Their highs is going to be the third quartile, which is this 98.6. That's kind of curious that the third quartile is at the what's considered normal, plus 1.5. 98.6 plus 1.5. I'm looking at my calculator down here. Gives me 100.1. Is there something that high on the males? So there's no highs. No high. See, this is why that 100.4 feverish is there. Oh, I see. Because, see, all these data things that I steal are real data from somewhere. Lows. That's going to be the 90. Oh, I don't know. What's it? 90. Oh, 97.6. 97.6 minus 1.5. 97.6 minus 1.5 gives me 96.1. 96.1 for the males. Well, the minimum is lower than that. No, wait. 96.3. No, it's not. 96.1 is like way down here. And there's nobody. 96.3 is the high. So no lows. So there's one cold female. I'm finding myself laughing at this. One cold female, no highs, no lows for males. Okay, draw parallel box plots to these two distributions. Be sure to label the points and provide a scale. Okay, so box plots. I'm going to actually use these same 96. I'm going to use this same thing up here. 96 all the way to 100. 100. And I'll just go 97, 98, 99. Oh, okay. I'm just going to use this. Okay, 90. Okay, males. Males have no outliers. So I'm going to do the males first. Males. The minimum is 96.3-ish. It's right there. So I'm going to put that there. I'm going to do the median now. The median for males. Median is 98.1. I get that there. So 98.1 is right there. So there. Oh, that's the median, not the quartile, you dingling. What's the first quartile for males? First quartile for males. First quartile. I'm going to find myself an eraser. Better than this one. Okay, there's something. First quartile for males, because that's the first part of the box, right? 97.6. So 97.6, that's a little more than halfway right there. 97.6. This is 98.1. And this is 96.3. I'm looking back and forth between this and this up here, right? Okay, that shows both. Okay, good. Now it's the median. Third quartile, 98 point. Oh, 98.6. That's 98.6 is kind of right here-ish. 98.6. And then maximum 99.5. 99.5 is right there. Female. Okay, the median female, 98.4, which is lower than this. So 98.4, right around there. 98.4. The third quartile female, 98.8. 98.8 is between there and there. So, and really, make sure these are good compared to each other. The maximum female is 100. And we know there's no female. The first quartile, no female, high outliers. And this is 100. The first quartile female is, 97.9. So 97.9 is kind of right here. Okay. And then this. Now, hold on. Time out. I know this is an outlier, right? That one there. And that's the only outlier at 96.4. So I'm going to put this 96.4 right here, and it'll be a dot. This bar is going to go to the next lowest. So I have to look here. The next lowest is right here, which seems to be right in line with this 96.6-ish. Yeah, or 75-ish or something like that. So it seems to be right there. This is... And now, I don't know, I know this first quartile. That's this 97.9 for the female. 97.9, that's a radio station, right? Okay, there's my 97.9. I don't think I can tell you exactly what that is. I know which dot it is. That this is sorry, I'm going back and forth. I know which dot that's representing that dot there. But I can't tell you exactly what it is, so I'm not going to put a label on it. But I know it goes right about there, 96.5. Oh, see, mine's right at 97, so it's not going to go right there. What is this? 96.5, 97. So this is like 96.75 or something. So it's down maybe here-ish or something. It'll go right about there. But I don't know exactly what it is, so I can't label it. But the big deal is this has no outliers. This has the one. There's the highest. There's the lowest non-outlier. Write a few sentences to comparing these distributions. Okay, this is where you better dang well see your socks. Okay, so I'm looking at these, and I'm going to say, Both distributions female and male body temperatures are fairly symmetric. They're not perfectly symmetric, but they're pretty close, right? And I look at these, the boxes are pretty darn symmetric. The tails are pretty symmetric. These are, even with that outliers, pretty symmetric. With females having, so I've taken care of shape, outliers. Females having one low outlier and no high, and males with no outliers. And if you're looking at my handwriting and saying, holy smokes, how can I read that? You know, they can read all kinds of handwriting. I've graded tens of thousands of tests, and I've only had one that I couldn't read, and that's pretty standard for people. Males with no outliers, period. Okay, shape, outliers, center. Comparing. Now, I compared the shapes when I said both are symmetric, and I compared the outliers where I said females has one outlier and they have none. But this is one where I can definitely use those comparative words like higher, lower, that kind of thing. So I'm going to look at the median. Oh, and you know what? And I have the mean up here. So I look, females have a higher mean. And, oh, no, that's a standard error, the mean. The females have a higher mean, and the females have a higher median. Okay. The mean and median temperature of the females is higher than the males. Okay, shape, outlier, center, spread. Who has a bigger spread? Well, I can look at visually. Oh, look, visual. Wow, they're a little bit close. So I'm going to look at some numbers here. Standard of the mean. Interquartile range. Well, let me think. The spread. Spread. Oh, actually, you know what? Look at these females. And the dot plots here a little better. The male goes from there to there. This is just a titch above that, but the females go up further. So the females distribution is more spread out. And I could calculate a range and say, you know, with the range of this to that. But really, when you're comparing them, that's generally going to be good enough. Yeah. Shape, outlier, center, spread, and I've got context. That's it. Okay? And every time you can compare in that, more spread out. The mean is higher. That's it. Okay? Okay. Whew. Next question. Number 12. The data below is the number of unprovoked attacks by alligators on people in Florida each year for a 33-year period. Wow. And it says construct a histogram for the distribution, choose an appropriate bin width, and be sure to provide a label and scale for each axis. Oh, I want to go back here for a second. A real common mistake, and I made it. Be sure to label the plots and provide a scale. Tick, title, I don't have it. Body, temps, okay. Label. I haven't made a label over here. Gender, and I didn't make a label at all down here. Temperature. Tick. Units. Gender, female, male. There's no real units. Temperature, degrees, Fahrenheit. Okay? Without these units, this graph was scored wide, would have been a half effort. Okay, never forget these. And this is a real common one. You might label this as gender, but forget female, male. You have to label the difference. They have to be able to look at that and say, oh, this is the one, this is the other. Okay? Okay. Labels, 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 labels. I can't emphasize that enough. Easy thing to get points for, easy thing to miss. In fact, if you put the labels without the graph, you might even get a partial there. I don't know. It's going to depend on the rubric. Okay. Sorry, another Coke break. Okay. Data, I know this. Unprovoked alligator attacks for a 33-year period. So there's 33. N equals 33. Okay. Now, in choosing my bin width, I want to look at my values here. I've got a low of 1, it looks like, and a high. Do. Highs, a 22, right? 22. So I need to get bins that will go at least from 1 all the way to 22. So I'm actually going to go 0. And you know what? I'm going to go 5. 5, 10, 15, 20, and 25. Now, when you make these, remember, you're going to either include the bottom or include the top, but not both. So this would either be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that kind of thing. I'm going to include the bottom because that's traditional. Okay, so, and this is, on these here, it is the, this is the number of attacks each year. And then histograms, you don't really need a label on your vertical axis because they are always pure counts. So, for example, if I had a bar that was 5 here, that means there were 5 attacks between 0 and 5, that kind of thing. So you could put number of years with that attacks or something like that. So I might do that, number of years, just so I can tell myself what it is. Okay, and I'm not going to put a scale there for a second until I get this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think 10 will do good enough because I can't picture any one of these having more than 10. So I'm going to go 0 to 5. 0 to 5. I've got, there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I don't count that because I'm including the lower. 5, 6. 1, 2, 3, 4, 5, 6, 6 right there. Okay. And now I like to put that number on top of my histogram just so I can know that. Okay. I'm going to, just so I know that I've used them, I can visualize, I'm going to just scroll that all in. Okay. And I know I haven't used 22. Okay. Between 5 and 10. So 5, 6, 7, 8, 9. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Whoa. So 6, 7, 8, 9, 10, 11. Okay. Now, by labeling these boxes here, I don't have to label here because I can go over here. That's 6, 1, 2, 3, 4, 5. So it should be easily figured out there. Okay. Okay. So but either from your scale here or here, you should be able to read what's there. I mean, I could go 1, 2, 3, 4, 5 and go 5, 6, 7, 8, 9, 10. So there should be enough there to be able to see what there's there. Oh, see what it is. Okay. Okay, now I need from 10 to 15. And I'm including 10 to 15. So there's 1, no, 2, 3, 4, no, 5. I don't include the 15. 6, 7, 8, 8, right? 6, 7, 8, so right about there. Okay, so scratch, fat. Now I'm going 15 to 20, including 15. So there's 1, 2, 3, 4, 5, 5 right here. 5. Okay, scratch all that. Yeah, it seems right. And now 20 to 25. 1, 2, 3, right? 3. 1, 2, 3 over here. Also, by putting labels, it makes it very clear what this is, so nobody's going to argue. Now, 6 plus 11, that's 17, plus 8 is 25, 30, 33. N equals 33. That's also just a confirmation I didn't miss any. Okay. This is unprovoked gator attacks. Here's my title, my label, my tick marks, Okay, great. Based upon your histogram, explain what numerical measure of spread, center and spread, would be best to use for this distribution. Explain your choice. Well, I'm looking at this. The shape is, and notice I just scratched stuff. Don't bother to erase it. Just scratch it off. The shape is skewed right, which, remember, for skewed distributions would be conducive to using the median and IQR. Okay, there you go. That's it. So I would use the median and the IQ. Why? Because it's skewed right. Oh, the shape, and I'm going to do insert of the distribution of gator attacks. I don't think that I'd have to do context here, but context, every time I want to make sure I do context. Now, this gives some testing skills. Don't bother to erase things or rewrite a lot of stuff. Cross out what you don't want to be read, and if you have something insert, just kind of say, stick it in there, insert it in there. The reader will read it like that, okay? They've been taught to do that. Okay, last problem. Wow, this is taking me a while to go through and explain. Okay, based on this table, do people's opinion of the alt-rock band Coastal Surface depend on their age? Here are some data that answer that question. Oh, look at this, I have totals. I think when I showed this in class, I didn't have totals. I wonder how I got these. Maybe I did, maybe I didn't. I don't know. Well, whatever. Calculate 3 conditional distributions for opinion of the band. 1 for each age group. So that means for the 11 to 14, I need to calculate conditional distributions for like. I'm basically going to recreate my table. Like, dislike, uncertain. 11 to 14, 15 to 18, 19 to 22. Okay, I know that I'm doing the distribution this way because it says the distributions for opinions. So the distribution's this, 1 for each age group. So I'm going to do a distribution of whether these guys like it. So the conditional is for opinion. So I'm doing this. Okay? Okay. Okay, so the distribution, 1 for each age group. So 1 for this age group, that age group, and that age group. So I need to convert these to percentages. So here, I'm going to go 18 over 63. So for this 11 to 14, I'm going to move here. I'm going to do everything over 63. So 18 over 63. That gets me, and I'm just going to go percentages. I'm going to round them to the whole number. 29%. And this 30 over 63, 30 over 60, 30 divided by 63 gives me 48%. And 15 over 63, 15 over 63, that gets me 24%. Okay, 15 to 18. I've got 38 over 65. 38 over 65 gives me 58%. So 58%, wow, majority of those people like them, huh? 10 over 65 gives me 15%. And then 17 over 65. So 17 over 65 gives me 26%. 26%. 19 to 22. So that's this right there. 40 out of 122. 40 out of 122 gives me 33%. And then 67 out of 122 gives me 55%. And then 15 out of 122, 15 out of 122 gives me 12.2, so like 12%. Okay, so there it is. Now, if I was going to do a graph, I would do a bar graph kind of thing. But I like the table because I can just copy that down and basically do percentages in each box. And all these were for this condition, and this. This is the distribution of opinions for each age group. Discuss the relationship between age and opinion of the band in 2 or 3 sentences. So I'm looking at these, some things that stick out. Look at this and look at this. So I might say that the majority of 15 to 18-year-olds liked the band, while 55% majority, and I might even say that 55%. Oh, disliked the band. Well, the majority of 11 to 14-year-olds liked the band. They liked them. So that sticks out. Other things. I'm looking at that 12%. Well, actually, that's probably good enough right there, isn't it? Or maybe this. Look at that. Nope, not 11. While the majority of not 11 to 14, 19 to 20. Okay, the majority of 15 to 18-year-olds liked the band. That's right here. 58. I need to do what I liked. Okay, and the majority of the 19 to 22-year-olds liked the band there. 11 to 14-year-olds liked the band least. Right? Okay. And then look at kind of this, depending on the age. There is clearly association. Whenever you're doing that, that should be something you say. There is an association or there's not. There is an association between age and opinion of band. What there is, association means whether or not you like or dislike these bands. In other words, your opinion of the band changes or is dependent upon your age. Depending on the age, the opinion changes. If all of these were the same, there wouldn't be an association. It means no matter what the age, it's going to be, you're going to have that. Okay, guys, that's it. The short and sweet answers are back there. Good luck studying for that.